So we're ready to set up a PCR reaction. If you were doing this in a laboratory, you probably would have more ingredients than this, but we have conveniently consolidated a lot of those together into something we're calling the master mix, which is MM here. So the master mix for us contains a buffer, contains the nucleotide triphosphates, and contains the polymerase enzyme. So this was recently on ice, and I'm going to work quickly to get this done so that we don't leave that off of the ice for too long. There's an enzyme in there that is a polymerase, and we want to take care of our enzyme as much as we can here. So master mix, other ingredients, we have our DNA that we extracted. So your table, your group might have one of these for each people, should have one for each person. And we also have our primer mix. So fairly standard in PCR. You might have a lot of ingredients that are common to every PCR reaction, but we're doing a unique combination of my DNA and the primers that are going to amplify the region we're interested in. So that's the combination here. We're going to put these amounts together as directed by the procedure of the document. And I want to show you the PCR tubes. They're smaller and they're thin-walled. So I picked up a couple different kinds of these. I don't know which one we're going to have for you in the lab. But if you want, you can kind of press on these and feel that they're really thin-walled. And the point of that is that these are going to go into an instrument that changes the temperature to make it hotter, cooler, many times over several minutes, up to an hour or more. And as the temperature changes outside, we want to transmit that temperature to the liquid inside. And so having a thin plastic wall on here makes that happen a little bit faster. So you can squeeze them gently, but if you ever find that you have broken these by squeezing them or some other reason, you want to discard these and start with a new one. I have two different kinds here, and they differ by the top. So you can see maybe that one is flat across the top on the left, and the other one has a domed top. The PCR process heats things up to almost boiling, and so there's a lot of evaporated water associated with the process. And usually there's a heated lid, and there will be on our instrument, that keeps the top of this hot and causes anything that has evaporated not to condense above kind of the active zone, which would be lower down in the tube. So the heated lid prevents condensation, and if there is any condensation, the domed cap is a little bit better at transmitting that condensed liquid back into the bottom. So this whole thing is going to get heated. It's all pretty hot all around, but it gets almost boiling and then back down to just hot several times as we go through this process. So I have mine labeled. I put my number on the top, 12. The flat ones are easier to write on. That whole upper surface is scuffed up so that it's not as shiny. That's intentional. When they make the plastics, they scuff a surface so that you can write on it. The domed top one, the dome is not scuffed, and so if you were writing on these, you'd have to write on this little ledge right by the lip there. So right somewhere on there, you can keep track of your number. And another good kind of a fail-safe is if you haven't, or if you say, let's say, lose your number that you wrote on the tube, if you keep these in order, then if one gets smudged, you can find out where it is based on its position or its relationship to the ones next to it. But I'm going to have fairly good confidence in my number 12 here. And then there's a tube that's a good size for these, or I'm sorry, a rack. So this rack is 8 by 12, and this fits these PCR tubes. So even though they're a little bit delicate, when they're inside of this rack, it holds them firmly so that you can push down with them with some force. All right, so I'm going to open that just enough to put my ingredients in. So following the instructions, I've got 10 microliters of master mix. And I need my, so I've got my gray top pipetter that goes with the clear tips here for smaller volumes. Master mix, 10 microliters. So pretty small volumes all around. The enzyme is kind of expensive, so we try to get away with smaller volumes if we can. All right, 10 microliters of master mix. Oh, that's not enough. 8 microliters of the primer mix. So back down to 8. Primer mix known as PV92. I'm going to give these a vortex also before I go. Good to vortex everything. Really, when in doubt, vortex. If you're going to mix anything, vortex before you grab it, vortex it after you've added it. And then finally, 2 microliters of our DNA sample here. Vortex that. So I'll just kind of show you how small everything is here. So that's everything. So total volume 10 plus 8 plus 2, 20 microliters for this whole thing. That's kind of standard for a PCR reaction. If you're careful about these, you can vortex them. Maybe kind of push it off to the side here. All right, so that's mixing. You also could try tapping them. I think I'd recommend the vortexing just to make sure everything gets mixed up thoroughly. Then we're going to put it on the thermal cycler. The thermal cycler is that instrument that will heat and cool it a whole bunch and has corresponding programs that go along with it. So inside of here, just a metal block and carefully designed so that the heat will transmit around here. So the computer controls what temperature the block is, then that affects what temperature the liquid is. And we'll pick our program on here and have it go through the heating and cooling cycles until we've made copies using the PCR reaction.